Welcome back to another physics tutorial. In this tutorial, we're going to look at an honors problem involving free fall. And the math for these problems are going to be very similar to the math we did in the previous motion problems, but the concepts are a little trickier. I'm going to kind of explain that right now, and then we're going to go through two examples. So if we take a look at the first example, we have Moops tossing a football straight up into the air at 35 meters per second. And it says how high does the ball go and what is the total time the ball is in the air. So we're throwing something straight up, and the reason these get a little funky is if I draw a picture here and he throws the ball up. Well, we have a few weird things happening because one, okay, our initial velocity would be 35, but when the ball comes down, our final velocity would be 35. And on the way up, A is negative 10, and on the way down, A is positive 10. And so we cannot look at this problem in its entirety. We can't look at it all the way from the very beginning, which is here, to the very end here. It just doesn't work. And to show you kind of what I mean, if we look at like the equation, this guy, if we plug in VF, and we plug in VI, and we don't even have a value for A, because do we plug in the negative or the positive? We don't even know. And if we do that, we subtract 35 from both sides, and the 35s just cancel. And so we get 0 equals A, which is either positive or negative 10. Right? A is positive or negative 10 times T. There's no way that's going to be 0. It absolutely falls apart, does not work. So when we look at these problems, we have to either look at the up part or the down part. We can only look at half of it at a time. And we're going to focus on the down part only. And the reason we're going to focus on the down part only is because when we do that, if we start here and we're only going down, our VI will be 0. And that's great for when we have this equation, because when VI is 0, this whole term just goes away and vanishes, which is good for us. The other benefit of focusing on the down only is right here. A is positive 10, so we don't end up with any negatives. And then we just have to keep in mind, okay, well, if we're trying to find the total time, well, we'll just take our answer for the down part and we'll multiply it times 2. Or if it asks us for the initial velocity and we're trying to solve for it, well, we'll get this answer instead, and we know those answers are the same because the up part is an exact mirror image of the down part. So when we have these problems, you just kind of have to think, okay, what exactly is happening? We're going to focus only on the down, but you might have to do something else at the end. So let's look at this example. So for our example here, we said we had Moops. We're going to focus on the down part only. So we know the final velocity is 35 meters per second. We know the initial velocity is 0. And we know that A is 10. So if we have our equations, and we have our x. So we know we're using these guys. This one is 35 equals 0 plus 10, positive 10, times t. So 35 equals 10t. Divide both sides by 10. And we get t equals 3.5. That is for the down part only. So when we look at this, and we want to see, the question asks for the total time, well, the total time is going to be 3.5 times 2, because we want the up and the down. So the total time will be 7.0 seconds. All right? So now we need the distance. We need to know this part here, how high is the ball. So we're going to look at our x equation. And we look at the x equation, we have x, and like I said, vi is 0. This term just goes to 0. It goes away. And so we have 1/2, positive 10, because we're on the down part, and t. So do we put the 3.5, the down part, or do we put the 7, the total? Well, we're trying to find the time in the air, not the time in the air, the height. So the height is going to go from the top to the bottom. So because it's going from the top to the bottom, we're going to use this time that we got from the top to the bottom. So that 3.5 is going to go right in here, squared. And we put it in a calculator, and we get 61.25 meters. Snazzy. All right, let's look at one more example. This one's going to be a little more confusing. We have Meeps hitting a volleyball 2 meters above the ground, straight up at a speed of 40, and we're trying to figure out how long it'll take the ball to reach the ground. So if we have Meeps here, and we have the ground, all right, so she's standing on the ground, and we know this distance is 2 meters. And she's hitting the ball from here up to the top. So we're going to break this down into 2 parts. We're going to break this down into the part above the 2 meter line and the part below the 2 meter line. So first off, let's do the above 2 meters. And remember, we have to do only one part at a time. We're going to do the down only. So we're talking about from here down only to here. Okay? So we know the initial velocity is 0 up here. And we know the speed down here. Our final velocity is 40 meters per second, which also happens to be the speed she hit it at. If she hits it from there, it goes up, it comes down. It's the same speed that she hit it. So we know, and we know A is positive 10. Okay, so above the 2 meter line, we have VI equals 0, VF equals, not 20, 40. VF equals 40. We know A is 10. All right, so let's do that. So we have this guy. We can plug our numbers in. We have 40. This one is just 0. And we have 10 times t. T equals 4 seconds. And remember, the 4 seconds is only from the top down to the line, the 2 meter line. Okay. We also want to know this distance. So the distance, I'm going to put this in a little checker box. We're going to need that later, so I'm going to kind of mark it there. It's not our answer, but I want to, keep it there. Okay, so our distance let's go black. Distance equals VIT plus 1/2 AT squared. And remember, this is still from the top down to the 2 meter line. This is 0. So we have x equals 1/2 10, that's going down, and the time. And we're only talking about the time in the top half going down, so we're going to use that 4. 4 squared. So x equals 1/2 of 10 times 16, which equals 80 meters. Okay, so this 80 meters, let me go up a little bit so you can see it. This 80 meters is only from the top down to there. This is 80 meters. Okay? But I want the total time. So what I'm going to do is I'm going to go from the very top. I'm going to go from way up here all the way down. All right? And I know that that distance is going to be 82 because I have this distance of 80 and then I have this distance of 2. So let's do that. So I'm going to go total down. The total down distance from the very top to the very bottom. We're going to use this equation. The total distance was 82 from the very top to the very bottom. From the very top to the very bottom, our initial velocity is still 0. So that term goes away. We have 10. And from the very top to the very bottom, we are trying to find that time. So we get 82 equals 5t squared. We divide both sides by 5. We take the square root, and we get a time of 4.05 seconds. That is the time from the very top to the very bottom. All right? So we're almost there. We have the time from the very top to the very bottom. We also have this 4 that we've been saving over here as the time from the top. This 4 is the time from the top to the blue line, to the 2 meter line, which is also a mirror image of from the blue line up to the top. So right now we need that. We need that 4 seconds from the blue line to the top, and we're going to add it to that 4.05, which is the total down, to find the total time. So our total time, let's extend the page. Total time will be the up, which equals 4 seconds, and the total down, which we said was 4.05 seconds. So the total time is 4 plus 4.05, which equals 8.05 seconds. Whew. All right. So, like I said, the math isn't any harder than it was before, but I think it's just kind of breaking the problems down and focusing on, okay, what do I have now? What do I need now? Where am I going? You kind of have mirror images, and you have to only focus on half the problem at a time. You can focus on the up part only. That will work, but I do think it's easier if you focus on the down only, because you have this VI will be 0, and you'll have terms canceling out, which is very nice. If you have any questions, please watch the video again. And if you still have questions, feel free to ask me. And hope you enjoy this presentation. Hope it's going to help you on your homework. Thank you for watching.